Welcome to ArchiCraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dima Golodiuk at demongo.com.
You're listening to the 7th episode of the podcast. This episode is titled Agentic AI Time Digest, New Architectural Imperatives in Enterprise AI. In this episode, we explore the new era of enterprise AI. Today's digest covers agentic frameworks, specialized models, unified governance, and advanced RAG for architects. Let's get started.
Welcome to the Deep Dive. If you're a senior architect, maybe a CIO or CTO, you already know AI in the enterprise. Well, it isn't just about picking a cool model anymore, is it?
Not at all. It's really evolving fast.
Yeah, into designing entire intelligent systems, the whole landscape is shifting. So we thought, what if you could get a shortcut? A kind of curated deep dive into the absolute bleeding edge of enterprise AI architecture.
That's the plan.
Our source today is Dmitry Golodiuk's recent Agentic AI Time Digest. The post is called New Architectural Imperatives in Enterprise AI. Now, Dima's work, it's an irregular digest, but it's specifically tailored, offering these timely, really crucial insights for leaders like you trying to navigate this space.
It really is. And our mission today, well, it's to unpack Dima's latest insights. We're focusing on what he calls this critical shift from a model-centric to a system-centric paradigm. So we're going to explore 3 foundational macro trends and then 5 key technical opportunities that are, frankly, reshaping the modern AI stack. And this directly impacts how you build resilient, value-generating platforms in the enterprise.
Exactly. We're going to get into the nitty-gritty, the architectural implications of things like agentic frameworks, these hyper-efficient specialized models, unified governance, and advanced retrieval augmented generation, or RAG.
Right.
But all from an architectural lens. This isn't just theory. It's really about what you need to think about building today. Okay, let's unpack this.
Let's get it.
So let's kick things off with Dima's first macro trend he identifies, the rise of agentic frameworks.
We're moving beyond simple AI features, right? Like just calling a summarization API.
Yeah, way beyond.
We're talking about designing these holistic kind of autonomous AI agents that can actually plan, reason, maybe use tools to achieve pretty complex goals.
And the crucial thing is, as Dima points out, is this isn't just, academic research anymore. These are rapidly becoming enterprise-grade solutions. Okay, so give us some concrete examples. How are these concepts actually showing up in enterprise offerings?
Well, what's really fascinating is seeing them in practice. Take Microsoft's Azure AI Founder Agent service. It's a service specifically built for sophisticated research agents. Architecturally, it's interesting because it enforces this distinct auditable workflow.
Auditable workflow. How does that work?
It starts with intent clarification, using something like GPT-4o to really nail down what the user is asking. Then web grounding, leveraging Bing search to get reliable data, which, helps fight hallucinations.
Okay. Grounding it in reality.
Exactly. Then that leads into deep research execution. Here, a specialized model, it's called O3 Deep Research, synthesizes information in a very step-by-step reasoning process. And finally, transparent reporting generates this structured, audible output complete with citations.
That sounds incredibly important for enterprise adoption, that whole auditable trail.
It absolutely is, especially when agents are involved in decisions or providing key insights in high-stakes domains like market analysis, where you just need that accuracy and traceability. It's non-negotiable.
Makes sense.
And then you've got IBM. They have IT Bench and AgentOps Bench. These are standardized evaluation frameworks specifically for industrial and IT agents.
Evaluation frameworks, so ways to measure how well they work.
Precisely. The significance of something like IT Bench, which Dima notes has 94 real-world scenarios covering SRE, FinOps, compliance, well, it's huge. It moves agent evaluation away from just sort of subjective feelings.
Like, does it seem smart?
Right, towards objective scientific measurement. This lets you really benchmark an agent's performance in solving actual problems, ensuring it's reliable and efficient before you deploy it widely.
And Google's Big Sleep for cybersecurity, that sounds like another specialized agent example.
Indeed, Big Sleep is quite different. It combines Google's deep threat intelligence with agentic search capabilities to proactively hunt for zero-day security vulnerabilities.
Proactive?
Yes. Its discovery of that Screelite vulnerability, CVE 2025-6965, before it could be widely exploited. That's a dramatic illustration of a major architectural shift. DEMA highlights in security ops. You're moving from being reactive to being truly predictive.
Wow. So your security architecture could actually become an offensive tool, not just defensive.
That's the potential, yes, a proactive force.
Okay, so with these sophisticated, sometimes autonomous agents running around, it feels pretty clear that MLOps, machine learning operations, managing the model lifecycle, probably isn't enough anymore.
You're absolutely right.
DEMA introduces this term AgentOps as a crucial new architectural discipline. Why isn't MLOps cutting it for these dynamic systems?
Well, think about it. MLOps is designed for managing models that, once trained, are largely predictable. They perform specific tasks. But an agent, its execution path is dynamic, it's often non-deterministic, it interacts with external systems through tools.
Right, APIs and things?
Yeah, exactly. And its potential for, let's say, rogue actions is significantly higher than a simple predictive model. AgentOps requires a whole new set of practices.
Like what specifically?
Things like rigorous governance over the agent's planning logic itself, meticulous lifecycle management for its tools and APIs, those need updates, security checks, robust state management, especially for long-running tasks, granular cost attribution becomes much harder with complex workflows, and crucially, specialized observability. You need ways to detect behaviors like goal drifting, where the agent forgets its objective, or tool misuse, or even hallucinated reasoning paths.
That sounds complex.
It is. And the strategic takeaway here for architects is that teams focused only on traditional MLOps are likely unprepared for this. It demands a broader system-level view that integrates risk management, security, and operational oversight right into the architecture from day one. You really can't bolt this on later.
That makes perfect sense.
Yeah.
So for those architects listening, DEMA actually outlines a kind of reference architectural blueprint for a robust enterprise agentic system.
He does. It provides a good starting point.
It includes things like an intent scoping engine, a governed tool and API registry, a planning and orchestration core, a secure execution environment, a state management database, and that comprehensive observability and audit layer you mentioned. It really forces that system-level thinking.
Exactly. And if you map it back to the examples, Microsoft Service, it exemplifies that multi-step research pipeline pattern for high-stakes analysis, validated by those auditable reports, IBM's benchmarks. They highlight real-world task simulation for IT ops, validated by scorecards.
Got it.
And Google's Big Sleep, well, that showcases a predictive threat hunting pattern for cybersecurity, validated by finding actual vulnerabilities like that CVE. The message is really clear. When you're architecting agents, you're architecting a complete system, not just deploying a model.
Okay, let's pivot then. The second macro trend DEMA highlights is maybe a bit counterintuitive, the development of hyper-efficient, smaller models.
Yes, a fascinating counter-trend to the huge general-purpose models that grab all the headlines.
So what's the architectural angle here? What's the economic case for these smaller, specialized models in the enterprise?
Well, this is really critical and, frankly, very pragmatic. It directly impacts your bottom line and how flexible you can be with deployment. For many real-world enterprise use cases, think about on-device processing, maybe real-time analytics and streaming pipelines, or those cost-sensitive batch jobs. These smaller specialized models are often just more architecturally sound and definitely more economically viable. They're designed to bring pretty advanced reasoning capabilities into environments that are constrained resource-wise. This unlocks new use cases that were previously impossible just because of those limitations.
Can you walk us through an example? DEMA talks about Microsoft's 5.4 mini flash reasoning. That's quite a name.
It is, but it's a prime example of this compression trend. Its efficiency comes from a radically different, very efficient new architecture called Sambay. Now, what you need to know as an architect listening to this.
Yeah, the key takeaway
is that this innovation means you can now run advanced reasoning models with up to potentially 10 times higher throughput. and maybe a 2 to 3 times average reduction in latency compared to its predecessor, 5.4 Mini.
10 times throughput. That's huge.
It's significant, and crucially, it can achieve this level of performance while being deployable on a single GPU.
Okay, that's the economic lever, single GPU.
Exactly. This dramatically lowers your total cost of ownership, your TCO, for dedicated workloads. It makes advanced reasoning much more accessible for a wider range of uses, especially where latency or cost is a major blocker, or where you absolutely need that on-device processing.
So this really signals a fundamental architectural divergence, doesn't it?
Yeah.
Architects can't just rely on a single pattern anymore, like, let's just call the big API in the cloud.
Precisely. Model specialization is driving architectural divergence.
It's forcing new choices.
Absolutely. Architects now need to consciously design for at least 2 distinct architectural tracks. First, you've got the maximalist track. This is for your large general-purpose models like the GPT-4 series. They excel at complex, creative, multi-domain tasks, but yeah, they come with higher latency and cost.
Right, the big guns.
Then second, there's the optimized track. This is for specialized, efficient models like that 5.4 Mini example. These are ideal for high-volume, low-latency, or cost-sensitive tasks that operate within a pretty well-defined domain-specific context.
And choosing the wrong track has big implications.
Profound implications for your entire system architecture. You actually see this pain point manifesting quite clearly when developers struggle with the complexity of some cloud platforms, maybe like AWS SageMaker Batch Transform for specific GPU and CVD versions. The generic cloud abstractions often just can't keep pace with these divergent needs efficiently.
And this divergence leads to distinct design patterns. Dan mentions things like an edge inference engine, a real-time analytics coprocessor.
Exactly. The edge inference engine is for on-device, maybe offline operation. The real-time analytics coprocessor fits into streaming pipelines needing ultra-low latency. And then there's the cost-optimized batch transformer pattern, focused on maximizing GPU use for high-volume, non-real-time tasks, maybe using very specific instance types. These patterns ensure that specialized models like 5.4 Mini Flash reasoning can bring complex reasoning to environments that were previously limited, maybe to much simpler models. And they do it while lowering that TCO for dedicated high-volume workloads, largely because you can deploy them on a single GPU.
So the strategy is about fitting the right model with the right architecture to the right problem, optimizing both performance and cost.
That's the essence of it. It requires more upfront architectural thought.
Okay, this brings us neatly to Dima's third macro trend, the convergence of data and AI governance. He really emphasizes that traditional manual governance.
Yeah, it's just not going to cut it in the AI era.
No way. It's untenable.
He says it must be automated, integrated, and enforced as code. This is a truly monumental shift we're seeing.
Right.
Governance is moving from being this sort of after-the-fact checklist.
Right, something you do before launch.
Exactly. To being a foundational, automated fabric that's woven directly into the entire data and AI lifecycle right from the beginning. Databricks AI Governance Framework, DAGF v1.0, is a really excellent blueprint Dima points to.
Okay, DAGF. What are its core ideas?
Well, it's structured around 5 foundational pillars. Things like AI organization, legal and regulatory compliance, ethics, transparency and interpretability, then data, AI ops and infrastructure, and finally AI security. It covers the bases.
And how does something like Unity Catalog fit into making that framework actually work?
Unity Catalog is essentially the technical enforcement layer for those DIGF principles. It offers unified governance, a single centralized control plane for all your data and AI assets. We're talking structured data, unstructured data, ML models, even AI agents and dashboards.
A single pane of glass? Sort of.
Pretty much. And it provides fine-grained access control using a hierarchical model. This allows for things like attribute-based access control, ABSE, where permissions are dynamic based on user and data attributes, plus row and column level security, dynamic data masking for sensitive stuff like PII.
Critical for compliance.
Absolutely. And for transparency, Unity Catalog automatically captures and visualizes end-to-end data lineage. Across pipelines, tables, models, dashboards, you see how everything connects, all the access, all the operations, they get captured in detailed, queryable audit logs. That's foundational for compliance, but also for FinOps governance, understanding costs.
And it works with external systems, too.
Yes, crucially, it supports federated governance. So you can extend these policies out to external data sources like SAP, Snowflake, Google BigQuery, and others.
Okay, so the core message here isn't just that governance is good practice anymore. It sounds like Dima is saying it's an absolute prerequisite for scaling AI and maintaining trust.
That's exactly it.
The whole move fast and break things era.
Yeah.
Definitely over for enterprise AI.
Absolutely. And this represents a fundamental reordering of priorities for you as architects. Governance architecture is now the primary enabling architecture. It's not some secondary task you tack on at the end. It has to be designed first.
So if you connect this to the bigger picture.
Right. The initial question for any new AI project has to shift. It can't be, okay, let's build a RAG prototype anymore. It has to be, what is our governance framework and how are we going to technically enforce access control, lineage, and auditability for the entire life cycle of this system?
Wow. That's a major shift in thinking.
It is, because without that foundation, your AI initiatives simply cannot scale responsibly. They'll fail security audits, regulatory checks, and ultimately they'll lose the trust of the business and your customers. It becomes a blocker.
Okay. Moving on, let's talk about the next big architectural imperative Dima highlights, the blurring of data planes. Now, for decades, we've lived with this pretty rigid divide between OLTP and OLAP, right?
Yeah, online transactional processing for the real-time operations and online analytical processing for those complex after-the-fact queries.
And usually that meant complex ETL processes, moving data between systems, introducing latency.
Exactly. And that traditional architecture, well, Dima argues it's fundamentally incompatible with the demands of real-time AI-native applications, especially these autonomous agents we discuss.
Why incompatible?
Because those agents often require a continuous, very low-latency feedback loop. An action happens, the resulting data needs to be immediately available for the model to make its next inference. That model's output triggers another action, and the cycle repeats almost instantly.
Okay.
The batch-oriented delay inherent in a traditional OLTP, ETL, OLAP pipeline, it just breaks that essential loop. It's too slow. So new architectures have to be, as Dima puts it, built for AI, not just retrofitted to support AI.
And he points to Databricks' acquisition of Neon, that serverless Postgres company, as a key indicator of this convergence.
That was a really significant move and a huge signal to the market. Neon's architecture is uniquely suited for this new world. Its serverless design, completely decoupling storage and compute, means you can rapidly spin up potentially thousands of isolated Postgres instances on demand.
Why is that important for AI agents?
Well, think about an agent needing to spin up an ephemeral database environment just for some safe experimentation, or maybe to run multiple paths in parallel. Neon makes that feasible. This acquisition helps Databricks create this truly unified, full-stack AI vision on one platform. Neon handling the real-time transactional workloads, Delta Lake for the large-scale analytical side, and Mosaic ML for the model training and fine-tuning. It really does blur those old boundaries.
And for AI agent workflows specifically, how does Neon actually impact them? Are there specific features?
Yeah, Neon has database features like instant branching and forking. These are incredibly valuable for agent workflows. They allow an agent to, say, clone a full working data set for safe experimentation without impacting the production data.
Like Git branching, but for a database.
Kind of, yeah. Or imagine an agent trying a complex multi-step task. It hits a dead end. It could instantly revert to a previous known good state of the data and retry a different approach. This enables much more robust, auditable, and ultimately safer agent execution pipelines. It's a potential game changer for complex agent actions in the enterprise.
That sounds powerful.
And ultimately, Dima suggests that integrating true OLTP capabilities right into the Lakehouse architecture represents more than just technical convergence. It's really the evolution of the data platform itself. It moves from being a passive data repository to, a warehouse or a lake.
Right, where data just sits.
Into an active operational intelligence factory. It's no longer just a system designed for analyzing the past. It becomes this dynamic operational substrate for the entire intelligent enterprise, where real-time data flows into a continuous assembly line consumed by intelligent machines that then perform actions back in the real world.
An intelligence factory. That's a really powerful metaphor.
It captures the shift, I think.
Yeah.
From passive analysis to active operation fueled by AI.
Okay, this leads us nicely to our final technical opportunity Dima covers. Re-architecting retrieval augmented generation, or RAG. We hear a lot about RAG, but the basic approach, just chunking text and using a simple vector database, Dima argues that's just not enough for complex enterprise data.
He's absolutely right. Enterprise data is messy, right? It's rarely just a nice, clean corpus of text files. It's a jumble of structured databases, semi-structured reports, complex legal documents, PDFs, images, unstructured files. Basic RAG implementations just fall flat pretty quickly.
So what's needed?
Dima's source highlights several advanced R techniques that are really essential for enterprise-grade solutions. Things like hybrid retrieval.
Hybrid meaning.
Combining dense semantic search understanding the meaning with sparse keyword-based methods like BM25. This gives you both contextual understanding and precise matching for specific terms. We also need structure-aware chunking. Instead of just splitting text every X characters, you parse documents based on their intrinsic structure sections, paragraphs, tables to keep the semantic meaning intact.
That makes sense. And especially for tabular data like spreadsheets or database tables.
Oh, critically important. Dima mentions table-specific RAG. This involves chunking that's aware of the table structure and maybe even indexing individual rows. This granular approach lets the R ecosystem answer highly specific row-level queries, which is just impossible with standard text chunking.
What else?
Other key techniques include query transformation and refinement. This is where you actually use an LLM to rewrite or expand the user's query before you even start the retrieval process, aiming for better quality documents. Then there's cross-encoder re-ranking. After an initial retrieval pulls back candidate documents, you use a more computationally intensive model to re-rank them for higher relevance, filtering out the noise.
Okay.
And finally, grounded prompting. This means instructing the generation model, the LLM, to anchor its responses solely in the evidence provided by the retrieval step, ideally with citations or summaries. This is critical for mitigating hallucinations and building trust and accuracy.
Wow. Okay. So the crucial point Dima seems to be making here is that RAG isn't just some feature you toggle on. It's actually a deep data engineering discipline.
That's exactly it.
And the ultimate performance of your RA system has less to do with which LLM you picked and much more to do with the quality and sophistication of that entire retrieval pipeline you just described.
Precisely. And this raises a really important question for you as a leader listening to this. A project that starts with the question, which LLM should we use for our RAG?
Well, it's starting from the wrong place.
Right.
The sophistication of these advanced patterns Dima outlines reveals that successful RAG is a deeply integrated data engineering and architecture discipline. Its success hinges on excellence in data engineering. The whole initiative should really be treated as a data architecture project first and foremost.
So the teams best equipped aren't just AI specialists. Not solely, no. They are often experienced data architects and engineers who have deep expertise in building scalable, reliable data pipelines. They understand data quality, structure, transformation, indexing, all the things that make advanced RAG work well.
What a phenomenal deep dive into Dima's latest digest. Okay, let's try to recap the main strategic imperatives here for the enterprise architects, the solution architects, the CIOs, CTOs listening.
Let's summarize.
Okay, first, embrace system-level thinking. Get beyond single models. You need to design the entire intelligence system end-to-end.
Absolutely. Second, build a bifurcated AI strategy. Recognize you need both those maximalist and optimized architectural tracks to fit the right model, the right architecture to the right problem.
Third, design governance in, not on. Automated integrated governance isn't an afterthought. It's a foundational requirement from day one.
Right. Fourth, prepare for data plane convergence. Start planning for those real-time feedback loops. Evolve your data infrastructure towards becoming that intelligence factory.
Fifth, invest heavily in data engineering for ABG. Success really depends on the quality of the retrieval pipeline, and that demands advanced data engineering skills.
And finally, sixth, prioritize AgentOps. This is a new, absolutely necessary discipline for managing the unique life cycle, the risks, the complexities of these emerging autonomous systems.
These aren't just technical trends, are they?
Not at all. As Dima lays out, these are critical shifts demanding new strategic priorities for your enterprise AI initiatives starting right now.
So hopefully you now have a clearer map for navigating these architectural shifts in enterprise AI.
And maybe leave you with a final thought, building on Dima's insights. Given this rapid convergence we've discussed today, agents, specialized models, unified governance, blurring data planes, consider this seriously. How quickly can your current organizational structure and your talent pool adapt to these fundamentally system-level architectural demands? We're not just talking model-level considerations anymore.
That's a big question.
It is. And maybe ask yourself, What legacy assumptions, maybe about data silos or about governance processes being manual checklists, might be slowing you down right now from becoming that true intelligence factory for your organization?
Powerful questions indeed. Something for you to definitely mull over and apply. We hope this deep dive into Dmitro Digest provides invaluable insights for your own organizations. Thank you for tuning in to The Deep Dive.
Thanks for tuning in to ArchiCraft. This episode was generated using AI from Dmitro blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.